The west coast of the United States stands as a focal point for seismic activity within the nation. While the fear of a major earthquake striking California remains widespread, nestled within the heart of the United States is one of the most active yet enigmatic seismic zones, the New Madrid seismic zone. Scientists believe this area will suffer from a series of devastating earthquakes in the near future, unleashing terrifying consequences that are beyond our imagination. Today, let's delve into the New Madrid seismic zone, a region often overlooked for its potential seismic activity, and examine what will happen when the earthquakes finally occur. Before we start, don't forget to click on that subscribe button and like this video, as it's the best way to support this channel. Often overshadowed by its more renowned counterparts in California, the Pacific Northwest, and Alaska, the New Madrid seismic zone stands as one of the most perilous seismic regions in the United States. Spanning across several states, including Missouri, Arkansas, Tennessee, and Kentucky, this seismic zone has the potential to disrupt the lives of millions of Americans. The origins of the New Madrid seismic zone trace back approximately 750 million years ago to the Precambrian era, during the fragmentation of the supercontinent Rodinia. This event triggered the formation of a rift valley, which over millions of years failed to fully separate the continent. It is this unresolved rift that created a vulnerable zone within the Earth's crust, setting the groundwork for future seismic events. Today, this ancient rift lies buried deep beneath layers of sediment from the Mississippi River, explaining the region's unexpected hilly terrain amidst an otherwise flat landscape. The Mississippi River, the lifeblood of this region, traverses through the heart of the New Madrid seismic zone, forming a broad alluvial plain that serves as a vital channel for commerce, agriculture, and transportation. This river's floodplain, characterized by nutrient-rich soils, has historically fostered extensive agricultural development. Alongside the river, the terrain gradually rises into the Ozark Plateau to the west, and the Appalachian Mountains to the east, offering a stark contrast to the flat floodplains. These uplands, with their rugged hills and forests, present a different facet of the region's physical geography, highlighting the diversity of habitats and ecosystems within the area. Seismic activity in the New Madrid seismic zone is characterized by intraplate earthquakes, occurring within the interior of a tectonic plate rather than along its boundaries, where such events are more typical. This oddity adds a layer of mystery, as these earthquakes happen far from the edges of the North American plate. Unlike regions defined by a single fault line, the New Madrid seismic zone is characterized by a network of faults crisscrossing the area. These faults lie concealed beneath the Earth's surface, posing challenges to their comprehensive study and understanding. This complexity is why many have never predicted a major earthquake striking this region, despite its history of inflicting significant damage. Today, the New Madrid seismic zone continues to be a significant concern for geologists and emergency planners alike. While it hasn't sparked any major issues recently, history has demonstrated just how devastating it can be. The most significant seismic events within the New Madrid seismic zone unfolded in 1811 and 1812. During this period, a series of powerful earthquakes ranging between magnitude 7.0 and 7.5 struck the region. The tremors were felt across an expansive area encompassing approximately 1 million square miles, surpassing the reach of any other earthquake sequence documented in the historic record of North America. Accounts from that era vividly depict ground waves visible as they traversed the landscape, rivers flowing in reverse, immense fissures opening in the earth, and intense shaking that brought down chimneys and trees. The town of New Madrid, Missouri, located near the epicenter of seismic activity, suffered extensive damage, while the regional landscape underwent permanent transformation. New lakes formed, and sections of the Mississippi River altered course, leaving an enduring mark on the region's geography. Due to the unique characteristics of the seismic zone, aftershocks reverberated in the region until 1817, a full 5 years following the initial event. Subsequent to these earthquakes, the area encountered several other notable seismic occurrences, although none matched the magnitude of those early 1800s quakes. The most substantial earthquakes since then struck on January 4, 1843, and October 31, 1895, measuring estimated magnitudes of 6.0 and 6.6 respectively. While not directly within the confines of the New Madrid seismic zone, a 5.4 magnitude quake on November 9, 1968, near Dale, Illinois, serves as a reminder that the entire region may be more seismically active than previously believed. In the years following the event, scientists have meticulously assembled evidence to decipher the long-term activity of the zone. Through this research, it was discovered that significant earthquakes have occurred within the New Madrid area at intervals of roughly 500 years over the past few millennia. Despite the irregularity of large-scale seismic events in the New Madrid seismic zone, in contrast to more active regions such as California, the potential repercussions of a major earthquake in this area loom large. The region's burgeoning population density and evolving built environment since the early 1800s have significantly heightened concerns for earthquake preparedness and resilience. Unlike the West Coast, where buildings and infrastructure are often engineered with seismic activity in mind, many structures in the central United States lack the strength to withstand the forces unleashed by a major quake. As a result, one of the most immediate and visible impacts of a significant seismic event in this region would be the extensive damage inflicted upon buildings and infrastructure. Critical infrastructure such as bridges, roads, pipelines, and power lines could also face severe disruption. This could result in significant interruptions to transportation and communication networks, with Interstate 55, vital for connecting New Orleans to Chicago, likely rendered impassable for an extended period. Moreover, the Mississippi River itself, a key artery for travel and trade, would probably become unusable. Historical evidence from the early 1800s suggests that the river could even reverse its flow temporarily, a phenomenon that could recur in a future earthquake. Even if such a reversal doesn't occur, debris would likely clog the river, hindering emergency response efforts and affecting supply chains, leading to shortages of food, water, and medical supplies. The Mississippi River carries over 500 million tons of imports, exports, and domestic freight each year. All of this vital commerce would come to a standstill on the nation's most crucial river if the earthquake occurs. In 1991, a Federal Emergency Management Agency report projected that damages from a 7.6 magnitude earthquake would be catastrophic. It estimated that approximately 2% of the population would be killed, up to 10% seriously injured, with around 10% of all buildings collapsing and 30% suffering severe structural damage within the nearest counties to the epicenter. The damage would amount to nearly $300 billion. These statistics underscore the potential human and economic toll of a major earthquake in the New Madrid seismic zone. Presently, the New Madrid seismic zone is populated by just over 2.1 million people. However, this population count does not encompass areas outside the region that would still bear the impact, such as St. Louis, Missouri, Nashville, Tennessee, and Evansville, Indiana. This indicates that a considerably larger population could feel the repercussions of a seismic event than just those within the New Madrid seismic zone. Interestingly, while many residents in this region may not anticipate an earthquake anytime soon, it is worth noting that Oklahoma has become quite accustomed to earthquakes despite lacking major fault lines or a long history of seismic activity. In recent years, Oklahoma has undergone an unprecedented surge in seismic activity characterized by swarms of earthquakes. These swarms, comprised of hundreds of small to moderate-sized earthquakes, represent a significant departure from the region's historically mild seismic patterns. What distinguishes this surge from seismic activity in other parts of the world is its link to human activities, particularly the injection of wastewater into deep wells. This process, known as deep well injection, involves disposing of the wastewater by pumping it into deep geological formations. While this method effectively disposes of the wastewater, it has also been